Let's take a look at these Q value. Um, the idea of the Q value is of course, the energy released. So notice if it's not released, then you'll get a negative number. Okay, so those are endoergic things. But basically what you want to do is just look at the left side, of the reactants, I guess, right? And then look at the right side. And if the right side has less mass, you should say, where did that mass go, right? Where did that mass go? And of course, the answer is that it went into energy, went into the kinetic energy of the particles, right? Heat, things like that, right? And if the right side has more mass, you're going to have to wonder, well, where did it come from, right? Well, it came from energy. It required the input of energy. That's an endoergic reaction, okay? So in summary, and I dedicate this to Ethan Putnam, okay, you have to ask, where did it come from? Where did it go? Where did it come from, Cotton-eyed Joe? Is that funny? I think that's funny. Are you laughing? I don't even know. All right. So basically the Q value then, right? Let's see if we have a formula, right? It's left minus right. If you look up the masses, right? So you got to look up all these masses, know what they are, right? Okay. Look up the masses and go left minus right. So add up the left side, add up the right side, and multiply by 931.5. In general, in this, like for this entire test, if you totally blank on what to do, just subtract some masses, multiply by 931.5. Seems like, that might work. You have to look up these masses. You have to know what tritium is, what an alpha particle is, and that's all in the video flip. What to use for a proton. Proton use hydrogen, right? And these masses are, let me show you. Okay, you'll find them when you look at that. There's that isotopic mass. So that's the reference you want to do. And these are stable isotopes. Okay, these are stable isotopes. And there's a whole bunch that are not stable. So notice there's our hydrogen, our deuterium, our tritium. And then remember for the alpha particles, you're going to use a neutral helium atom. And then you just have to look up the other ones. There they are. They've got, 6 digits past the decimal point. Notice that carbon is exactly 12 because it defines the atomic mass unit. It is defined as 1/12 of that. Okay. There also is notice that the neutron isn't on there because it's actually not stable. Isolated neutrons decay. Not ones in atoms, thankfully, right? But there it is right there. So there's our mass of the neutron. You want to use the U one there. Okay. So those are not too difficult. I don't think. I mean, you'll get the hang of it. It's basically just like binding energy, only maybe easier. I don't know. And then for these fission reactions, the first thing is, and of course you saw this in the video flip, you got to figure out how many neutrons, right? So you got to do a little math here, just balance it. And I just did this. I've seen this a couple times on an IB test, so maybe they'll give you that. And then notice that I give you these masses, and that's because our table that we have, I'd love to use it, but it doesn't have unstable isotopes, just stable ones, right? So all the products of fission reactions are pretty unstable. This, by the way, means that they're toxic and they're radioactive, and some of them have half-lives of 10,000 years. So this is one of the problems with nuclear power, is that you generate all these highly radioactive isotopes that don't normally occur. So anyway, but this is exactly the same thing as the previous thing where you're trying to find the Q value. Only these are tremendous Q values. Okay. And then what I did was I actually went into the course modules, and I have made this essay 30.2. It was supposed to fall, actually fall on, well, you could see here. It's supposed to fall on the day after break. But, the way that's going to work is you'll forget everything, and then, it's like, oh, well, golly. Which maybe that's good. I don't even know, right? So what I'm going to do is I'm going to actually make that thing available. It's available now. It just has an end date. So the end date for this thing is 10 a.m. Tuesday, but it's available from, well, it doesn't even have an available from date. It's available now, and it has been published. You can see a little blue or little green dots by them, mean they're published. So you should be able to see one. Let me know. Well, it'd be too late then. Actually, you could email me over break. I'm pretty sure I've got everybody assigned to one. Okay, so that's the other pro tip, right? Is that notice that in that next week there's a 5 billion video flips. So my strategy, if I were you, is I just buzz through these. These are not hard. I would do that practice test, submit it. I would do my essay, maybe do it over the weekend, or even just do it Friday. I mean, it's not. This is fairly straightforward. Okay, this one's maybe a little harder, but not really. I would do those, and then on this day, just be working on all these video flips. Okay. Yeah. Oh, Feynman group quiz. I like how it's due here. I have to fix that. It's not due there. It'll be due. I don't know. Down there. Anyway, so and then just pep talk about IA. I would get that done if you can get it before break. But we will have time in class. I mean, after there's a day here, and then we start working on IAs. Okay, so, and we'll be just doing that in class. There won't be any new content. So, I think that's it. Oh, the joke. You need a joke. I'll post the joke later.